Welcome to my topic Circuits and Networks. I am Ravikant Malajoshila. For the past classes, we are dealing with single phase AC circuits. So in this class 7, we are also going to see some more numericals involved with RL and RC circuits. So we'll start off with the basic problem of RC circuit applied to AC. Here you can see RC circuit of 22 ohms and 80 microfarads is applied across 110 volts 50 hertz supply. We need to calculate capacitive reactance, impedance, current in the RC circuit, phase angle, and instantaneous current equation. So we have seen this kind of numerical in our previous classes, especially the problem involved with RL circuit. So let us solve the circuit. We know that the capacitive reactance is given by Xc is equal to 1 by omega c, where omega c is known as angular frequency, whose value is given by 2 pi f. So substituting the values of omega, 2 pi f is given as 50. C value is 80 microfarads. So 80 into 10 to the power of minus 6. This 10 to the power of minus 6 shifted to the numerator becomes 10 to the power of 6. This will give you the value of Xc equal to 39.78 ohms. Then let us calculate the impedance. Impedance in its magnitude form is given by under root of R square plus Xc square. R is the resistance. So its value is 22 square plus Xc just we calculated 39.78 square. So this value is obtained to be 45.45 ohms. So this is the impedance of the RC circuit. Then according to Ohm's law, I is equal to V by Z. So V value it is given here as 110 volts divided by total impedance, that is 45.45, whose value is obtained to be 2.42 amperes. So this is the value of current. And how to calculate the phase angle? First elaborate tan phi, which is nothing but the reactance component to the real component. So the reactive components we obtain to be 39.78 ohms and the real value is resistance, that is 22 ohms. So tan phi is equal to this value. This indicates the tan phi value to be 1.8. So this is the value of tan phi. Once we obtain the value of tan phi, we can obtain the value of phi, which is equal to tan inverse of 1.8. 39.78 divided by 22 will give you the value as 1.8. So tan inverse of 1.8 will give you the value to be phi as 60.94 degrees. So this is the value of phi. In fact, this is also known as the phase angle. So it is leading, since it's a RC circuit, the current leads the voltage. Now, according to the maximum value of current, Im is equal to I root 2, where I is the instantaneous value of current. Sorry, it is the RMS value of current. We need to calculate the instantaneous value of current equation. For that, we are estimating the Im value, which is equal to 2.42. This is the RMS value of current, what we have estimated, root 2, which will give you the value of maximum current as 3.42 amperes. Now, once we obtain the value of current, maximum current, let us also see what omega is. Omega is, as I told you, it is 2 pi f, whose value is 314 radians per second. Just we substitute the value of f is equal to 50. Then we can get the value of instantaneous current equation as I, small I denotes the instantaneous value of current, which is equal to maximum value of current sine 314t plus 60.94 degrees. This is the lead, that is why we have taken 60.94 plus inside the current equation. So this is how you calculate the current values, angle values, and you estimate the instantaneous current equation for RC circuit. In the next problem, you can see if the peak current occurs 1 by 800 seconds before the peak value of the voltage, then obtain the power factor, average power, and circuit parameters for an RC series circuit applied to 220 volts 50 hertz supply, which is drawing an RMS current of 15 amperes. So voltage, current, the frequency, the values are given. We need to calculate power factor, average power, and other circuit parameters with the condition of that the peak current occurs 1 by 800 seconds before the peak value of the voltage. So this is the main condition given to us, and the parameters given to us this voltage, current, and frequency, and we need to estimate the power factor and average power. So how do we do that? So in going to the solution, we have to take the condition first. Since the time interval of 1 by 50 seconds corresponds to 2 pi or 360 degrees. 360 degrees it is in degrees and 2 pi it is in radians. So 1 by 50 seconds corresponds to these two values. So 1 by 50 corresponds to this value. So 1 divided by 800 corresponds to which value? So it corresponds to 22.5 degrees. How do we do that? So 1 by 50 corresponds to 360 degrees. It is known fact for AC circuit. So 1 by 800 corresponds to, let us take the unknown parameter to be x degrees. Then multiply the cross multiplication standards and you are going to obtain the value of x degrees to be 22.5 degrees. I hope you understood this simple calculation. So now the phase angle, which is the 22.5 degrees, it is obtained to be the value of 5. Now once the phase angle is obtained, the power factor is simple. Power factor is nothing but cos of phase angle. So cos of this value will give you as 0.923 lead. Why it is lead? Because it's a RC circuit and that is why it is leading power factor. Then calculating the average power, which is given by VI cos phi. So V value is 220, RMS value of current is 15 and cos phi value is 0.923. Just multiply these values, we are going to obtain the value of average power as 3045.9 watts, or sometimes it is treated as 3.045 kilowatts. Both the answers are one and the same. So once we obtain the average power, let us calculate the other parameters. One parameter is impedance. Impedance is equal to V by I. So 220 divided by 15 will give you the value of impedance as 14.66 ohms. Now once the impedance value is obtained, we can easily obtain the value of resistance. So 14.66 cos of phi for RC circuit, R is equal to Z cos phi. So this value is obtained as 13.53 ohms. Similarly, we can obtain the capacitive reactance from the impedance triangle of RC circuit. You can see what is impedance triangle of RC circuit from our previous classes. So X is equal to Z sin phi. Just substitute the value of phi value. Phi is 22.5. So 14.66 sin 22.5 will give you the value of Xc to be 5.61 ohms. Now once we obtain the capacitive reactance, we can obtain the capacitance. C is equal to 1 by 2 pi f xc, because xc is equal to 1 by 2 pi f c. So just we have interchanged the values. So C is equal to 1 divided by 2 pi, f is 50 and xc we got as 5.61. So this will give you as 5.67 into 10 to the power of minus 4. So this is the value of capacitance in farads, or you can just change it the value to 567 microfarads. So these are the other parameters. Resistance and capacitance are the other parameters of the circuit which are needed to be obtained according to the given problem. In the next problem, you can see a coil having a total effective impedance of 100 ohms and carries a current of 5 amperes. The phase angle measured between the current passing through it and voltage measured across it is 45 degrees. The coil is connected in series with 50 ohms resistance and the entire series resistance is applied across a sinusoidal input. We need to find what exactly is the supply voltage and circuit phase angle. So here, unlike previous problems, the input was not given and which is required us to estimate. So in fact, this is the circuit according to the given description of the problem. You have voltage in series with 50 ohms. It is given as 50 in series with the coil. So this is a coil. Coil is supposed to be consisting of resistor and inductive circuit. So you have resistance of the coil as well as inductance of the coil. These two are the part of the coil parameters. And what is the current flowing here? The current is flowing as 5 amperes. So this is the diagram drawn according to the given problem. What is the requirements? The requirements for the given problem are effective impedance. So effective impedance I am treating as ZC, which is equal to 100 ohms, which is nothing but R plus JXC, where R can be obtained as the effective impedance cos phi terms, which is equal to ZC is 100. 100 multiplied with cos phi. Angle value is 45. So cos 45, which is nothing but 1 by root 2. So 1 by root 2 times 100 will give you the value as 70.71 ohms. I hope you understand this with numerical. Once we obtain the value of R, we can also obtain the coil reactance. This is not Xc, this is called reactance. Coil reactance, which is nothing but the coil value of the impedance times sin phi, which is the same value, 70.71 ohms. Here it is not capacitive reactance. Here we are taking as coil reactance. So don't get confused. Here we are treating Xc as coil reactance. Is this clear? Okay. So fortunately, the angle is 45. That is why we are getting the values of R and Xc are same. Here the Xc is of the coil reactance. Now once we obtain the value of resistance, calculate the total resistance, because R is in series with the coil resistance. The coil resistance is R and the resistance small r is nothing but 50 according to the given problem. You can see here this small r is 50 and the resistance of the coil is 70.71. Is this clear? So that is what we are taking here, R plus R, which is equal to 50 plus 70.71, which is nothing but 120.71 ohms. So this is the total circuit resistance. Estimate the total circuit impedance, which is equal to under root of R square plus Xc square. Now here this R I am treating to be the total circuit resistance. So total circuit resistance is 120.71 square plus 70.71 square. What is the 70.71? This is the coil reactance. Coil reactance. This is not the capacitor reactance. It is the coil reactance. Please don't get confused. According to the given problem, we have changed the parameter. According to the problem statement, we have changed the parameter of Xc as coil reactance. So this value is nothing but under root of this. So the total circuit impedance is obtained to be 140 ohms. 140 ohms is the total circuit impedance. Now once we obtain the value of total circuit impedance, we can calculate the voltage applied, which is equal to 5 amperes into 140 ohms. 140 ohms is the total circuit impedance, which is obtained as 700 volts. Now once we obtain the input voltage, calculate the circuit power factor. So circuit power factor we are treating here as cos phi circuit, indicating the circuit power factor, which is nothing but R total by impedance. R total, as I told you, this R here is equivalent to R total. R is equivalent to R total here. So this entire value of resistance, the total resistance is nothing but R total. That is nothing but 120.71 divided by 140. So 120.71 divided by 140, which is equal to 0.86. So this is the value of circuit power factor. Once we obtain the circuit power factor, we can easily obtain the value of phase angle to be, the phase angle of the RC circuit to be cos inverse of 0.86. So the value of phase angle of circuit of RC network applied to the voltage of 700 volts is obtained to be 30.68 degrees. So this is how we solve the problems involved with RC and RL circuits. I hope you understood this particular basics of the AC circuits. In our next classes, we'll try to solve some more numericals which are related to single phase AC circuits. So in today's class, we have dealt with basic problems in RL and RC circuits. This we are treating as a subclass of 2 under single phase AC circuits of class 7. I hope you like this video. Please share among your friends, subscribe to my channel and press the bell icon for the future notifications.